The following PowerPoint will provide an overview of Down syndrome, common characteristics of people with Down syndrome, the different types of Down syndrome, causes and risk factors that attribute to Down syndrome, health issues of people with Down syndrome, diagnosis and diagnostic tests available for Down syndrome, and the impact on motor development that Down syndrome has on people. The last slide contains references. Babies are normally born with 46 chromosomes. People with Down syndrome, also known as trisomy or trisomy 21, are born with an extra chromosome. This extra chromosome affects brain and body development of people with Down syndrome, and as a result has the higher probability of causing mental and physical challenges. Despite people with Down syndrome may look and act similar, each person is different in terms of ability, and generally have a mild to moderate low-range IQ and speak slower than other children. There are some common characteristics that are prevalent with people with Down syndrome, and they include a flattened face, especially through the bridge of the nose, almond-shaped eyes that slant up, a short neck, small ears, tongue that tends to stick out of the mouth, tiny white spots on the iris of the eye, small hands and feet, a single line across the palm of the hand, small pinky fingers that sometimes curve toward the thumb, shorter in height as children and adults, and poor muscle tone, scientifically known as hypertonia, or loose joints, scientifically known as ligamentous laxity. There are 3 types of Down syndrome. People often can't tell the difference between each type without looking at the chromosomes, because physical and behavioral features are similar. Trisomy 21, the most common type, roughly 95% of people with Down syndrome. This type of Down syndrome, each cell in the body has 3 separate copies of chromosome 21 instead of the usual 2. Mosaic Down syndrome affects approximately 2% of people with Down syndrome. Mosaic means mixture or combinations. Some cells have 3 copies of chromosome 21, but other cells have the typical 2 copies of chromosome 21. Children with mosaic Down syndrome may have the same features as other people with Down syndrome. However, they may have less features of the condition due to the presence of some or many cells with the typical number of chromosomes. Translocation Down syndrome. This type accounts for a small percentage, approximately 3%. This occurs when an extra part or whole extra chromosome 21 is present but is attached to or translocated to a different chromosome rather than being a separate chromosome 21. Heredity is not a factor in trisomy 21 or mosaicism, but in 1/3 of translocation Down syndrome there is a hereditary component, accounting for about 1% of all cases of Down syndrome. Cause and risk factors of Down syndrome. Down syndrome leads to physical and developmental challenges. Scientists know that Down syndrome is caused by this extra chromosome, but they are not sure why it occurs and what factors play a role. Women over 35 are at a higher chance of having a baby with Down syndrome, despite a majority of babies being born to a mother less than 35 years of age. But this is due to a larger number of women being pregnant under the age of 35. The following dot points provide some information on health issues with people with Down syndrome. People with Down syndrome have a higher chance of health problems and lower immunity. There is a higher risk of issues with sight and hearing. They may also have stomach, heart defects or hypothyroidism, or problems with their bones. People with Down syndrome will have issues with learning and speech as well. A healthy diet and physical activity are important for people with Down syndrome. They have an increased risk of being overweight, low thyroid levels, and osteoporosis. Other health problems include hearing loss, obstructive sleep apnea, ear infections, eye diseases, and heart defects present at birth. Diagnosis. There are 2 basic types of tests available to detect Down syndrome during pregnancy: screening tests and diagnostic tests. Screening tests can reveal whether the pregnancy is lower or higher chance of having a baby with Down syndrome. Diagnostic tests can detect whether a baby will have Down syndrome, but this can be risky for the mother and developing baby. These tests cannot predict the full impact of Down syndrome on a baby. No one can predict this. Some more information on screening and diagnostic tests. Screening tests often include a combination of blood tests and an ultrasound. During an ultrasound, technicians look for fluid behind the baby's neck. Extra fluid in this region could indicate a genetic problem. Diagnostic tests are usually performed after a positive screening test in order to confirm a Down syndrome diagnosis. Types of diagnostic tests include chronic villus sampling, CVS, which examines material from the placenta. Amniocentesis examines the amniotic fluid. Precancerous umbilical blood sampling, also known as PUBS, examines blood from the umbilical cord. These tests look for changes in the chromosomes that would indicate a Down syndrome diagnosis. Impact on motor development. There will be mild to moderate delay in physical development. This includes poor muscle tone, previously mentioned, hypotonia, which affects strength and endurance, broad, short hands and fingers, which decreases coordination for gross and fine motor activities, and decreased sensory processes, which impacts participation in all environments. There is limited research on children with Down syndrome and motor development, but within that research, it is obvious motor development is delayed in children with Down syndrome. The NDSS suggests hypotonia is why children with Down syndrome have delayed motor development, as the floppy appearance seems to make motor development difficult. But Saxby and Buckley and Malik et al. Believe that because children with Down syndrome's cerebrum is reduced in size, have brain maturation disorders, slow cognitive development, and pathophysiological processes are the reason for delay in motor development. This is the end of the PowerPoint, and this slide includes the references used for the previous information. The next topic that will be spoken about is Down syndrome through the application of dynamic systems theory and/or other appropriate theories, covered by Renee Fisher.
Thanks, Caaleb. I'll be examining the issue Down syndrome with the application of dynamic systems theory in relation to motor development. Motor development is a key aspect of any child's development. The ability to move, reach, walk, and talk are linked to motor development. According to Colombo 2017, most adults with Down syndrome meet their motor development milestones. Researchers have summarized that those with Down syndrome acquire motor skills much slower than those without. This is due to several structural defects common to children with Down syndrome that are not seen in children otherwise, and offers the explanation for the delay in these motor skills. Motor delay in infants with Down syndrome can be seen from months 4 to 6, according to Lobo, Galloway, and Heathcock 2015. Characterization and intervention for upper extremity exploration and reaching behaviors in infancy. Infants with Down syndrome kick their legs significantly less than those without, and can relate to factors such as high incidence of muscle co-activation, low muscle tone, ligamentous laxivity, and muscle weakness. Furthermore to this, the cerebellum is smaller, influencing posture, adjustment, and the sensory system. Dynamic systems theory is that, according to Galenia and Shoemaker 2017, the body is a complex system composed of millions of interacting parts. The intelligence that coordinates the body is not localized in any one particular part, but emerges from the complex interactions of all the different parts. The base premise of dynamic systems theory is that movement behavior is the result of complex interactions between many different subsystems in the body, the task at hand, and the environment. In relation to development of motor skills in those with Down syndrome, we can already see that many of the subsystems in the body are falling behind due to the structural deficiency caused by Down syndrome. The brain sends delayed signals to an underdeveloped body that struggles to interact with the task at hand, and without these simple interactions with the motor development falls further and further behind. According to Rose and Fisher, 2009, this aligns with the two base principles of dynamic systems theory. Firstly, multiple characteristics of person and context collaborate to produce all aspects of behavior and movement. And secondly, variability of performance provides important information for understanding behavior and development. Dynamic systems theory talks of plasticity, which is the role of the environment. The environment is critical in the way the brain develops. The idea is that the brain is able to change and adapt and wire itself to certain sorts of demands that depend on the environment. Environment plays a role when it comes to development of motor skills in both developing children with Down syndrome and without. Picture a 10-year-old child. Dynamic systems theory states that if you throw a ball to the child, that the brain will tell the body to catch the ball, and likely that ball will be caught due to the developmental changes that the child has gone through. A child with Down syndrome will likely not, due to the development delay associated with Down syndrome. Picture again a child with Down syndrome who has grown up in a household that has prioritized sport or these motor developmental skills. That child now has a distinct advantage due to the environment it has been exposed to. Brain plasticity occurs through a person's lifetime. However, the brain tends to change a great deal during the early years of life. Therefore, being exposed to the sporting environment early on will help gain and strengthen the motor development. As the brain is more responsive to experiences at a younger age, meaning that the environment would play a big factor in shaping the brain's plasticity. Now on to Jana, who is discussing the implications for practical learning and teaching.
Thanks, Renee. Reflecting on the findings of how Down syndrome affects motor development and skill execution, there will be a reflection on the dynamic systems theory, which involves the movement behaviors of individuals through a range of subsystems in the body. It is essential to reflect on how Down syndrome can affect practical learning and teaching, and how interventions within a learning environment can be integrated into teaching pedagogy to enable students with a disability to access education on the same basis as similar aged peers with reasonable adjustments in accordance with the inclusive education policy. The main identified factors which implicate skill learning and execution for individuals with Down syndrome include a delay in physical development, a small cerebellum, hypertonia, ligament laxity, muscle weakness, and broad and small hands and feet. These factors all implicate learning and teaching as they result in impairments in functional performance, including fine and gross motor skills, strength, endurance, postural adjustments and balance, sensory systems, and coordination. These implications cause challenges within motor functions as a delayed sensory system slows down simple tasks such as sitting, crawling, walking, writing, and catching a ball. The integration of the DST can be evident through the intervention of deficit skills in students with Down syndrome and how the complex interactions between many different subsystems in the body, the task at hand, and the environment can affect student outcomes within an inclusive classroom environment. Reflecting on two main implications for practical learning and teaching involve coordination and balance, where the facilitation of movement patterns, motor skills, and the refining of quality movements need to occur while being mindful to prevent injuries. Coordination is a major factor which is influenced directly by the common characteristics, including broad small feet, hands, and shortened pinky fingers, which can curve towards the thumb, as well as hypertonia and postural stability. Coordination interventions involve beanbag tossing games, concerning throwing beanbags or bigger, smaller, heavier, or lighter objects into a target area which can vary in size, which is an example of good quality vestibular input which is required for great educational outcomes in Down syndrome individuals. The implications on the practical learning utilizing the DST in the target activity involves the poor or overcompensated grip, slower reaction times, floppy movements, poor balance, strength, endurance, and joint and postural stability. In relation to the DST areas of the task at hand and the environment, there needs to be modifications made to the objects and distance which is being incorporated. By varying the weight of the objects, it allows students to engage in a throwing object which suits their level of adjustment, as the environmental factor can affect student outcomes by not providing the student with appropriate material to engage for participation. Balance is another major factor which is influenced directly by the common characteristics including broad small feet, hands, and shortened pinky fingers, as well as hypotonia and postural stability. Interventions for balance involve outdoor and indoor agility course walking routes which involve straight, complex, short, or long Illinois agility test courses. The modifications to these tasks involve the level of speed and distance the student can complete the task with, as another factor is the low muscle tone and hypotonia, ligament laxity, and muscle weakness, which affects strength and endurance, postural adjustments, and sensory systems, therefore not allowing students to sustain long-distance tasks. In relation to the DST with the task at hand and the environment, these implications are almost the very basics to executing walking activities from low to high speed with short to long distances, ranging in the environment of the activity including the surface, weather, distance, and speed, and determine whether a student can complete the task at hand. Reflecting on the implications for teachers is the area of decreased sensory processing which creates problems for the motivation of students. The motivation of the student will be a massive issue for the teacher, as the delayed motor development will limit and play a role in their performance outcomes within the classroom. This lack of skill will lead the student into a negative mindset where there is no motivation or interest within the activities, as they will not be accurately achieving peak performance outcomes alongside similar aged peers. Therefore, to keep students interested, engaged, and motivated, the teaching strategy of modifying the level of tasks within an activity allows all students within the inclusive classroom to engage at a level which suits their performance levels. By having multiple level tasks, it allows students to freely move between the levels, where their social engagement and emotional investment will peak due to the compatibility to their personal performance standards. Another aspect of teaching strategies is chunking of instructions, as it is mindful in the gap of skills which exist in an inclusive classroom. By delivering small steps to an activity for the students, it allows all students to engage in skills together rather than having more advanced students within a task, creating a sense of competition for the less advanced students within sport and activities. Therefore, by trunking the delivery of steps for the interventions, it allows Down syndrome students to execute small skills alongside other peers within the inclusive classroom. Thank you for listening.